is on managing Kong on EKS with Kong Gateway Operator. So let me invite Animesh Rastogi to the stage. Animesh is a senior SRE at Kong. He specializes in cloud native development and distributed systems. So over the past 3 years, he has cultivated deep expertise on Kubernetes and its related technologies. I think it makes him trusted in that authority. Okay, let me hand over the mic to him.
Thank you. It's pretty awkward being introduced like that. Can everyone hear me? Do I need a mic? Sorry. It's fine, right? Yeah. Fine. So, yeah, essentially the talk, first of all, has anyone managed Kong or has anyone used Kong or uses Kong right now for Ingress? One person, that's it? Two, three, four, five, okay. Good, some people. Oh, camera, you know. Right. So 5 people. What do all of you guys do for Ingress or Northwest and East-West traffic? Do you guys just use regular old Nginx Ingress or cloud provider or API gateway? Like API gateway. Everyone uses API gateway. Yeah, I mean of course. Sorry. Yeah. Yeah, sure. I mean, just trying to get like a vibe of the room, right? Okay. So, just to give you a quick context for people who don't know what Kong is, right? Kong is essentially an open source API management platform, right? So it is a superset of what an API gateway is, right? Now, API gateway on AWS essentially, we are one of the biggest customers of AWS essentially, right? So what we do, we have 3 flavors of gateway that we provide, right? So first of all, our Kong gateway is completely open source, right? So you can just use open source Kong gateway on your Kubernetes cluster or VM, whatever you prefer, right? And run it like that, right? And then flavor number 2 is manage control plane. So Kong gateway provides you, 2 components, 2 distinct components. A control plane component where you configure all your routes, all your services, the URLs to the upstream services, all those stuff, right? And the data plane, which is the actual proxy pod, right? Proxy container, proxy component, where the control plane essentially pushes configuration out to these data plane component, right? So you configure it at the control plane level using the admin API, and that gets pushed down to the data plane, right? So the 3 flavors that I was talking about, you can run both of them yourself, right? You can choose to have control plane as a managed SaaS offering, which we call as Connect. And then you can also, which the product that I'm working on, which is the data plane part as well, you can choose to essentially have it provided as a SaaS solution, run it on our cloud, and we can provide you private connectivity and stuff, right? So essentially in this talk, I'll be talking about how we use Kong Gateway Operator in our situation, right? So as you can imagine, we have, let's say, 50 or 100 customers who want to run their data plane pods on our cluster, right? On our infrastructure. So we use Kong Gateway Operator essentially to manage that configuration and essentially ensure that that becomes a self-healing process, and an engineer does not have to, orchestrate the entire fleet and be, go inside, upgrade, and all those stuff, right? The management of day-to-day, because, we have like hundreds of cluster running. That's just in dev. And then in prod, you have like 500, 600 clusters. You can imagine the toll that it might take if we decide to do it manually. So that's what we use. We use Kong Gateway Operator. And I'll explain what it does, right? Where we got to it, how did we get to it, right? And what are the features that it offers you, essentially, right? So that's just a bit of a context for people who don't know what Kong is, right? So I'll just talk about Kong's journey to Gateway Operator. What is a managed gateway and why a managed gateway is needed, especially in a Kubernetes owner. So I'm assuming everybody knows Kubernetes here. KubeCon was, how many people are in KubeCon, by the way? Missed you as well. But yeah, let's talk afterwards as well, right? So yeah, why the managed gateway is needed. So I'll talk about managed gateway in Kubernetes context, right? What is the Kong Gateway Operator and how to deploy and essentially administer your Kong installation using KGO. We call it KGO, right? So first of all, let's talk about how we got there, right? the journey. So we started with Ingress like everyone did, right? Back in 2018, we launched our component called Kubernetes Kong Ingress controller, right? So Ingress API has been around for a long time, and we were one of the first ones to implement the Ingress spec, and it went complete GA in 2020. So Ingress essentially, everybody must know the big Ingress CRD that you essentially use. You deploy an Nginx or one of the Ingress controllers in the cluster, and you deploy big Ingress CRDs with all your paths, all your everything. And then if you want to have namespace isolation, you create multiple Ingress classes, Ingress objects. So you specify everything in this big Ingress object, right? And how does Ingress work in context of Kubernetes and Kong? Is you deploy a Kong Ingress controller, and that Kong Ingress controller essentially doubles as this control plane as well as the data plane concept, right? So you have both control plane and data plane in a single deployable, and it provides you with multiple CRDs. It provides you with the Kubernetes native CRD like the Ingress CRDs, but it also understands some custom CRDs which are Kong specific CRDs. Now for people who don't know what Kong is, Kong essentially is a pluggable architecture, right? It's designed to be pluggable. So what that means is, for example, authorization, right? In a previous session, we saw that if you want to do authorization with API gateway, you need to go to trigger a Lambda function to do it. So any custom code that you want to run needs to run on a Lambda or some other process that the API gateway has to invoke. That becomes costly at scale. What if you can have all of these, custom authorization code, or at least integrations with those custom services, for example, Vault, HashiCorp Vault, or Authorizer service, OID service. All of these things is a plugin architecture, right? So our Ingress controller also understands these custom CRDs. So for example, there is a CRD called Kong plugin, right? So you can configure some custom plugins as well, just using the Kong Ingress controller. And what happens is you define your Ingress object, and the Ingress class is specific to Kong, and then Kong will essentially take care of the routing and stuff, right? So that has been working, and we still work on it. We still actively, contribute to it. We still actively develop it, right? And this Ingress also, by the way, supports the gateway API, the new gateway API that has come out for Kubernetes, right? So it's very much one of our priorities. But yeah, we all know the limitation of Ingress, right? If you've run a large cluster before, you know that Ingress essentially is pretty clunky, right? If you want to support multiple controllers, you have to specify the Ingress controller annotation, and then annotation. Using these annotations, you have to specify custom controller specifications. For example, if you're using Nginx, using Kong, it just becomes very clunky, right? So what essentially the gateway API does, has anyone heard of Kubernetes gateway API or used it before? Right. So gateway API is the next iteration of the Ingress component of Kubernetes. So Kubernetes has stopped, freezed all developments on the actual Ingress API, and the new preferred way to do it is using the gateway API, right? So what that means? So with the new gateway API, how that looks like is essentially like this, right? So you have three main components. One is the gateway class. So the gateway class is essentially what the infrastructure providers provide. So let's say if you're running it on AWS, then it can be the AWS LB, right? Or if you want to use your own, for example, Kong, then the gateway class will be the Kong component, right? The gateway is the actual gateway that is running, right? Which actually routes traffic. So gateway class, the CR, which you say that, okay, this is the gateway class that I want to use, and the gateway is the actual deployment, right? And then the developers have their individual HTTP route, TLS route, TCP route that they can configure. So those paths that you specify in Ingress object, you can essentially distribute them, and the gateway API knows how to reconcile all of them, right? The providers which are which essentially comply to the gateway API knows how to convert all of them into the native gateway code, right? So that's what the gateway API essentially does. So you can create these HTTP route, TLS route, TCP route in different namespaces. You don't have to have it, in the same namespace or create it in different namespaces, right? So that is what this gateway API essentially does. So let's talk about why the managed gateway is needed, right? So this is essentially what it is. So you can essentially deploy your own Kong ingress controller. You can deploy your own Kong deployment, right? That's completely okay. But why manage gateway, right? What is manage gateway and why manage gateway? So, let's say you have a cluster, and I hope all of you don't, provision different cluster for different applications. But if you want to run a multi-tenant cluster where you have different applications running on different namespaces and different use cases, serving different use cases, both for east-west and northwest traffic, north-south traffic, right? You need to have multi-tenancy, right? In most of the situations, at least that I have seen, you need multi-tenancy is key, right? So using gateway API and using these gateway class and Kong gateway operator, you can create these multi-tenant gateways, right? And these are some of the benefits that it provides. I think everybody understands that benefits of multi-tenancy and what you need, right? So the general solution is the current solution that is used by most people is essentially deploy different ingress controllers, right? And you distinguish them by ingress class. So you have different ingress controller. One is running Nginx controller or Kong itself. That's fine. You can have you need to have multiple deployments of the Kong ingress controller, and define different ingress objects for you to be able to achieve the multi-tenancy that you want, right? You don't want the same gateway, or even if you want the same gateway, you want it to essentially have software level multi-tenancy, right? And that's very difficult to do with the current implementation of ingress controllers, right? Deployment management are a pain. And yeah, if you deploy multiple ingress controllers, you have to have the problem of actually operating them, making sure they work fine, making sure the configuration is completely tweaked, right? You're using the correct CPU requests, CPU limits. You are upgrading them in a zero downtime fashion. It's a pretty painful thing to do. And yeah, the reason I essentially can talk about this is because before this KGO went GA, we used to do the same thing. And yeah, it was a pretty painful process because our customers' traffic is going through our cluster, right? And we want to ensure that traffic is not dropped because that's an SLA breach from our side, right? So yeah, that's where Kong Gateway Operator came into the picture. It was essentially a closed source project when we started out, right? Till 1.0, it was completely closed source. And then we announced it as an open source project in KubeCon 2024 EU, right? To ensure that we get multiple issues and contributions to the community. And I have to say, like, the community is really active. Thankfully at Kong, we get a lot of PRs, like, and especially issues, which I think is much more important from our end, right? To understand what the customers' use cases are. So what are some of the things that Kong Gateway Operator basically provides you? So automatic cert rotation, that is, I'm sure everybody can understand, right? So the Kong Gateway or the ingress, if you want to do TLS termination, right, you have to have certs. So it provides you with a automatically manages your certs life cycle. It also ensures the communication between the control plane and the data plane objects are also encrypted, right? That is very, very important for security and compliance requirements. And in my experience, for SOC 2, you definitely need to have that. And most organizations need to have at least SOC 2 level compliance, right? Latency-based auto-scaling, right? You can define auto-scaling based on multiple parameters. The classics are CPU-based, but if you think about it, right, Kong or any sort of API gateway is running at an L7 level. It can also support L4, but mostly L7, right? And L7 latencies are really, really important. So it can also give you latency-based auto-scaling. You just have to define it as a field in the CR. It can also do HP, as I said, right? Manage data plane instances, cert rotation, auto-scaling, and one new feature that we have launched called AI Gateway, which I'm really excited about. Has anyone heard of what AI Gateway is? Okay, so AI Gateway essentially is an API gateway which knows about generative AI, right? That's essentially it. So what it allows you to do is it allows you to have essentially a governance layer before your applications reach out to generative AI, right? So from your perspective, what you are doing is you're making an API call using a particular prompt, right? Now you, as an application developer, do not care about individual implementation of different clients for, let's say OpenAI. Because OpenAI, Azure, Bedrock, everyone returns different API responses. You don't want to be able to handle it, separately. So all you do is basically make an API call to this AI gateway, and the AI gateway essentially based on the policies that your company has specified. So for example, you want certain amount of requests to go to Azure, certain amount of requests to go to OpenAI, right? You can configure that there itself, right? You don't have to manage API keys in your application as well. You don't have to have it, let's say, in a vault somewhere, and each application refers to it using external secrets operator or whatever. You can have those keys directly at the AI gateway level itself. So it's a pretty powerful feature. It also lets you do semantic caching, which we really use heavily, right? Where essentially you don't, so if you think about it, right, you have multiple prompts going out. You don't want multiple requests also to go to the OpenAI endpoint or the API endpoint. If they essentially mean the same thing, right? So it also allows you to do semantic caching, which, as you can imagine, reduces the costs of these endpoints quite significantly, reduces latency as well. So that's really helpful, right? So it also supports AI gateway. So that was the overarching point. Yeah, so main features, full lifecycle management of gateway, upgrades. It allows you to do upgrades using blue-green, right? So I'll give you an example how we use this for. So since we provide managed gateway, there's customers need to choose which version of managed gateway they use, right? And they can essentially upgrade, downgrade, whatever they want, right? Based on their use case. And if you can think about it, right? It is a great candidate for KGO, because if, let's say, someone is running 3.7 version and they want to upgrade to 3.8 version, right? Without losing any traffic, how do you do it? Blue-green, right? That's how you do it in normal application. But if you had to implement it yourself, it's really difficult to do it, right? The Kubernetes deployment object does not allow you to do it. So KGO essentially creates a new replica set, it forwards traffic there. So all of these processes it does, right? Elastic scaling, as I said, automatic certificate location, AI gateway, you can deploy AI gateway as well. And it also allows you now, in the 1.4 release that has gone out literally last month, we also allow support for PDBs as well, right? Because if you're running multiple instances of API gateway, you want to ensure that they are, some instances are always running, and due to some upgrades or something, they don't go down. So it also supports PDB. Connect control planes. So when you remember I said that managed control plane is a SaaS solution that we offer. So up until now, KG only supported open source deployment, but if you are using SaaS, you can also use the connect control plane. So it understands connect control plane as a separate CRD, essentially, right? Right, so how do you do HPA-based auto-scaling, right? So if you see, this is the custom resource definition, custom CR for the data plane. So control plane, data plane which actually proxies traffic. So how do you do HPA-based auto-scaling, right? You have scale up as a particular field in the CR, right? And this particular field, you can configure how you want it to scale. If you have something like KEDA as well running in your cluster, you can integrate this with KEDA as well, and it seamlessly integrates, right? And KGO essentially knows in case any of these field changes, basically reconciled. It's a Kubernetes operator, right? So it reconciles based on your changes. Now, how to deploy managed gateway on EKS, right? So as you can imagine, KGO is available. So I'll explain exactly how you do it. So first of all, you need to have an EKS cluster, right? Yeah, so once you have an EKS cluster, it's just 3 steps, right? You can have a Helm install that you can do, right? And it will instantly install the Helm chart, which is required to run KGO in the cluster. It will also install all the relevant CRs, right? Not the gateway CRs, because that's the Kubernetes CR, but it installs the relevant CRDs in your cluster for custom Kong related CRDs, right? You can have it using Helm install, Helm upgrade, or you can also use Argo CD, Flux, whatever you need, right? To kind of do it in a GitOps manner, which I think most of us essentially use. So what we do when a customer comes and they want, let's say, a managed gateway, for example, right? They say, I need a managed gateway. So what we do is we have built our own custom controller, right? What that does is as soon as customers says that I want a new cluster, that's the desired state. So our controller goes ahead and creates an EKS cluster, right? We have a repo that we use called Bootstrap repo. That Bootstrap repo has these Helm release files, And when we deploy, as part of our deployment, we essentially deploy those KGO. And once the KGO gets deployed, KGO basically takes care of the actual deployment of the data planes, the control planes, right? And from a customer's perspective, it's completely abstracted. What they tell us is deploy a 3.8 version of Kong gateway with 5 nodes, right? And a scaling policy as such, right? That's all they need to do. What we do is we create a EKS cluster for them. We deploy those CRs, we deploy KGO, and then KGO will manage everything, the entire life cycle of it. All we have to do is we have to ensure KGO keeps running, right? Yeah, so there is a gotcha, of course. Yeah, so how do you do it, right? You remember I said that there are, okay. So let's start with gateway class. So you remember this diagram? Yeah, this diagram. So 3 main components: gateway class, gateway, and route specification, right? The actual path. Right, so let's start with this gateway class, right? Gateway class is the actual desire that Kubernetes will now understand that, okay, Kong is the one that you're using. And in the spec, you need to have this controller name as this, right? So this will tell the gateway class or the gateway API that Kong is the actual controller which is going to be using this or actually providing the gateway, right? Once you've defined the gateway class, you define the actual gateway. So when you define the actual gateway, you have to define the gateway class name as Kong. Now, Kong gateway operator KGO understands this CR, right? It understands the CR and the previous CR. And what it will do is it will deploy 2 main components. One is a control plane component and a data plane component, right? These 2 components, and it will also deploy certs. It will also deploy, all these things that needs to make the communication work. Once you have done this, you can specify an HTTP route in any of the namespace that you want, right? And if you have these you have to have this parent ref, right? That's just a gateway API thing. Once you've done this, Kong gateway operator again also understands this. So what it will do is it will take this HTTP route, it will make the relevant API calls to the control plane, right? To create an HTTP route in Kong, right? And that way, from your perspective, you're using completely open source gateway API spec, but in the background, it will make sure that the control plane keeps running, the control plane has enough components. And of course, when I say this HTTP route or this gateway, this is a very bare bones implementation. There are hundreds of configurational tweaks that you can add to this particular spec as well, right? So that way, what happens is, from your perspective, it's completely abstracted out, right? You're using the native open source one, and it will automatically change it. So I'll give you an example what that means, right? So Kong is essentially built on top of Nginx, right? And we use something called as Lua JIT, right? To inject custom code inside the Nginx itself, right? Process itself. So what happens is, Nginx everybody has worked with, we know that how high performant it is. But Nginx is also pretty old now, right? And we have introduced something called as expression-based router, which is completely rewritten in Rust, right? So what we are doing is we're slowly rebuilding the entire Kong gateway in Rust because we have seen that it is much more performant, memory safe as well. So what that means, depending on the version of Kong gateway we want to deploy, the Kong gateway operator knows what flavor of the router you're using, right? So let's say if you're running an older version of Kong gateway where this does not exist, the router, Rust-based router, essentially what it will do is it will make the API calls to comply with the previous one. And if it's a newer version, it will use that, right? So Kong gateway operator, so the point essentially what Kong gateway operator does is it reduces the burden on you as a platform operator, right? To run and manage Kong. Because Kong is like a entry point of all your traffic, right? So even if your application is working fine, if Kong does not work or if the ingress controller doesn't work, none of your traffic is served anyway, right? So you really need that. Now, in addition to this, all of this, how do you manage, not manage, but how do you monitor KGO, right? Because now if it is doing all of these things and the manual task is reduced, you need to ensure that it is running, because if it is not running, then nothing works, right? There's nothing that happens. So how do you manage Kong, monitor Kong? Gateway operator. So Kong gateway operator, first of all, gives you different levels of logging. By default, it's error level logging, right? But you can enable verbose logging as well. And what that will allow you to do is it will give you info level logs as well, right? The reason that is done is because a lot of people use something like Datadog and a SaaS tool, and if you have a lot of logs being flushed, well, you're bankrupt. And I have seen that personally, where a customer, I remember customer left their proxy as well as Kong gateway operator logs running for too long, and it cost them about like 50K USD. So that's pretty costly, right? So that's why it comes with just error-based logging, and then it also exposes a /metrics endpoint, right? Which you can configure your Prometheus to scrape Prometheus-based metrics. So the metrics it can give you is quite varied, right? So first of all, it gives you how long it takes to reconcile and how long the object stays in the queue for reconciliation. Also, it will also give you how many of them are running currently. It will also give you what is the health status of it. It also gives you, if the deployment is working fine or not. So it gives you a lot of these metrics. So you can, at least from our perspective, what we do is we have KGO metrics being sent out to a central Victoria metrics cluster from each of the clusters. So how that works is we deploy individual Prometheus as all the clusters that we deploy, right? All the 500, 600 clusters. They do a remote write to a central Victoria metrics cluster, and we have a Grafana sitting on top of them that essentially we can look at all of these metrics from a central place. So that way, what we essentially do is we have to just ensure KGO works, because we know if KGO is working, all the data plane deployments are mostly healthy, and upgrades also work, and all of these also work, right? So anything that happens at the customer level, right? So customer says that I want, let's say, 5 instances of data planes, right? I want 5 instances of Kong running. So what happens is it comes to our API, backend API. That backend API interacts with the actual Kubernetes cluster. It makes that change in the CR itself, and then KGO takes care of the actual reconciliation process. And we get to know in case something is wrong and it is not able to reconcile, we're able to understand. Also, KGO provides you with a very, very nice validating webhook as well, right? So any wrong configuration is very rare to get pushed out to the actual cluster, which can be catastrophic again, because it's an actual ingress thing that happens. So this is essentially how you do manage Kong on Kubernetes. So that essentially was my talk. So I wanted to keep this as short as possible. I literally removed some slides last night as well, because it's just before lunch. So any questions, or we can close the talk.